Hi, we're Team Asclepius, and we've been tasked with developing a new bronchoscopy model for the Duke University School of Medicine.
A bronchoscopy is a medical procedure that allows pulmonologists to view a patient's airway and is used to diagnose various lung conditions. A thin, flexible tube with a camera, called the bronchoscope, is inserted through the patient's nose or mouth. Current bronchoscopy training models train medical students to determine their location within the bronchi based solely on images from the scope, and mostly focus on training for insertion of the scope. However, medical professionals must be able to use tactile feedback in addition to camera images to navigate through the bronchi. Our product aims to provide medical students and instructors feedback on the location of the bronchoscope during a training procedure, as well as display the full path taken during the procedure. To accomplish this, we created a 3D printed model of the bronchi and placed reed switches along the outside of the model to act as sensors. A touchscreen displays the current location of the scope and allows the user to toggle between current location feedback and a display of the overall path traveled. All of these components are housed in an acrylic enclosure.
Our project uses reed switches to determine the location of the bronchoscope. Reed switches are open switches that close in the presence of a magnetic field. By attaching a magnet to the tip of the bronchoscope and mounting reed switches at various locations on the model, we can determine the location of the bronchoscope based on which switch is closed. We also created a custom printed circuit board to integrate the various electronic components of our design.
The circuit employs resistors of varying resistance in series with each switch in order to convert the digital output from the switches into an analog output. Because of the different resistances, different voltage drops are associated with each switch closure. An analog pin reads this voltage drop, which is used to determine the location of the bronchoscope tip. To ensure a constant output voltage, a voltage regulator is used.
The touchscreen displays two different screens, one for current location feedback and one that graphs the overall path traveled. Each screen has a button for the user to switch between screens as needed. The location of the bronchoscope is shown by drawing dots on an image of the bronchi, where the dots correspond to the locations of the reed switches. When a reed switch is closed, the dot will turn green to indicate that the scope has reached this point. The screen also displays a timer so that the user can know how long the training procedure has lasted, as well as a reset button for ease of use, which resets the timer and clears all stored data. Each time a reed switch is closed, the number of the switch that was closed and the time at which the switch was closed are stored in different arrays. This data is graphed on the second screen, with time on the x-axis and the switch number on the y-axis. A key is mounted next to the screen so users know which location corresponds to which switch. The x-axis scales automatically based on how much time has passed, allowing us to display information concisely for procedures of various lengths. The purpose of this graph is to allow users to determine the path they traveled by looking at which switches were closed and in what order, as well as show how much time they spent at each location.
To make our bronchi model as anatomically accurate as possible, we used a pre-made STL file from Sketchfab as our base. However, printing that alone wouldn't yield a hollow model, so using Rhino 6, we offset the mesh by 3 millimeters to form a solid wall around a hollow interior. The final model was printed using an orange polylactic acid filament to replicate the color inside a dimly lit bronchi and to ensure our model was stable with repeated use and could be cleaned easily. To print, we split it into two segments, the trachea and the lower bronchi, and fastened them together using Loctite 401 adhesive.
Our housing model for the bronchi and electronics is made out of acrylic. The top and bottom panels were carved from a 1.5 by 1.5 feet sheet of acrylic, while the side panels were carved from a 3 feet by 1.5 sheet of acrylic. The height of the model is 5.5 inches, with the overall dimensions being a hexagon. The side and bottom panels have a 1/8 inch finger joints along the edges to be joined together like puzzle pieces for added stability, with the center side panel having an opening for the trachea piece and our team name on the front-facing side panel. The top panel has a 2x3 inch cutout for the display screen. We used an acrylic bender to make the curves of our housing model. The pieces were then joined together using superglue and silicone, with the hinges for the top panel being added by acrylic cement. The entire housing was coated with frosted spray paint to prevent the trainees from seeing inside the model.